Sample problem 2.1. In part A, both water and hydrogen peroxide are composed of hydrogen and oxygen. When water is decomposed into its constituent elements, it produces 0.125 grams of hydrogen for every gram of oxygen. When hydrogen peroxide is decomposed, it produces 0.063 grams of hydrogen for every gram of oxygen. Determine the whole number ratio of grams of hydrogen per 1.00 grams of oxygen in water to grams of hydrogen per 1.00 grams in hydrogen peroxide to show how these data illustrate the law of multiple proportions. Okay? So the idea here is essentially that if you take two compounds, there's water, and there's hydrogen peroxide. The issue is, how do we know those are the chemical formulas of those two compounds? One way is through the law of multiple proportions. So what happens is, when you decompose water, so you break it down into hydrogen and oxygen, now hydrogen actually forms H2 and oxygen forms O2. That's not particularly important for us here. But essentially what happens is, the number is, every time you get 0.125 grams of hydrogen out of the water, you get 1.00 grams of oxygen. Okay? That ratio is essentially fixed. So if you decompose a lot of water or a little water, you will get 0.125 grams of hydrogen for every gram of oxygen. So if, let's say you got 2 grams of oxygen, you would get 0.25 grams of hydrogen. The ratio is fixed. Now, here's what happens if you do the same thing to hydrogen peroxide. Now, hydrogen peroxide, when it decomposes, it actually generally decomposes into hydrogen and water. I'm sorry, into oxygen and water. It doesn't decompose into hydrogen and oxygen, but we could figure this out anyways. What happens is, it's 0.063 grams of hydrogen for every 1 gram of oxygen. So you see how the numbers are different for hydrogen? They're the same for oxygen, but they're different for hydrogen. The reason is, what we're doing is we're doing something called a normalization. We're not claiming that no matter how much water you decompose, you'll get 0.125 grams of hydrogen. What we're claiming is you'll get 0.125 grams of hydrogen per every gram of oxygen. And for the peroxide, hydrogen peroxide, for every 1 gram of oxygen that you get out of the compound, you'll get 0.063 grams of hydrogen out. Okay? So really all you need to do then is just to say this. If we take the hydrogen that's in the water, so I'll put in parentheses water, and you divide that by the hydrogen that's in the peroxide, hydrogen peroxide, it's 0.125 grams divided by 0.063 grams. And if you do that division, it's not exactly, but it's very close to 2. That's called the law of multiple proportions, meaning that there's twice as much hydrogen per gram of oxygen in water as there is in hydrogen peroxide. It's a 2-to-1 ratio, essentially. Now, the reason for that is that in water, there's 2 hydrogens for every 1 oxygen, whereas in hydrogen peroxide, there's 2 hydrogens for every 2 oxygens. So in a sense, there's half as much hydrogen in peroxide, at least relative to the oxygen, as there is in the water. Water is more hydrogen rich, and hydrogen peroxide is hydrogen more deficient. It's less rich. Okay? That's the law of multiple proportions. Now, the second example here is really just the same thing. They give us sulfur dioxide. Now, the chemists that were doing this stuff, they maybe didn't know the chemical formulas. They were actually figuring out the chemical formulas from the measurements of masses. They would measure these masses and then figure that out. So for sulfur dioxide, it's it's 1 gram of sulfur and then 0.9978 grams of oxygen. So here they're doing it relative to sulfur. How much oxygen is there relative to 1 gram of sulfur? So same thing, if you have a gram, this is SO3. If you have a gram of sulfur, it turns out you have 1.497 grams of oxygen. That's a 3, I'm sorry. Okay. So again, the issue is how much oxygen is there in sulfur trioxide relative to the amount of oxygen that's in the sulfur dioxide. So I'll write it as oxygen in the SO3 divided by the oxygen in the SO2. And it's 1.497 grams per 0.9978 grams. Now again, if you do that division, you get something around 1.5, meaning there's 1.5 times as much oxygen relative to sulfur in the SO3 than there is in the SO2. Well, 1.5 is the same as 3/2. So it's a 3:2 ratio of oxygen relative to sulfur in these two compounds. So you see the 3 there? And you see the 2 there? These are called chemical formulas. And the way we determine chemical formulas is by doing these sorts of mass measurements. You decompose the compound into its constituent elements. You measure the masses of those elements. You normalize it so that one of them is a gram and the other one is relative to 1 gram. And then you can do these calculations. So that's the law of multiple proportions.